All right, welcome back. If you are a little tired, if you're falling asleep a little bit, now's the time to do a little jumping jacks, a little push-up, maybe grab some caffeine because this is normally one of the harder days of the whole semester, and that's solving by the quadratic formula. Now, before we get to it, we have to remember a couple things about radicals. We got to remember how to simplify them. And when we talk about radicals, we're talking about the perfect square list that you guys had received this year. When we do 1 times 1, that should give us the number 1. If we do 2 times 2, that gives us the number 4. If we do 3 times 3, it's 9, 16, 25. 6 times 6 is 36, 49, 64, 81, 100, 121, 144. Ooh, that's kind of a bad 4. 169, 196, 225. I think those were the ones that we asked you guys to make sure that you knew. So we're going to be simplifying radicals a little bit with this day. So the square root of 36, it's asking you what two numbers multiply to give me 36. And that's actually on my list up here. I'm going to circle it. It's right there. So if we did the square root of 36, that should give us 6, because the two numbers that would multiply by themselves to give me 36 is 6. Now 50, there are no two numbers that multiply by themselves that would give me 50 that wouldn't be a decimal. So the first thing we have to do is find the biggest perfect square that goes into 50. So 50 lands right between 49 and 64. So in my calculator, I do 50 divided by 49, and I see if it goes into that evenly, and it gives you 1.02, so that's no. Then I do 50 divided by 36. Let's see if that goes in evenly. That's 1.38, so that's a no. Then I'm going to do 50 divided by 25, and that gives me 2. So I know that I can divide this 50 into the square root of 25 and the square root of 2. The square root of 25 I know can simplify down to 5. So then I have 5 square root of 2 left over. And that'd be my simplified version of the square root of 50. That's what we're going to be doing today when we solve by the quadratic formula. And then if we get the square root of a negative number, this is when we don't have an answer. So we can't take the square root of a negative number. There's no real answer to this. So that's my answer here. You're going to learn how to do the square root of negative numbers in Algebra 2 in 2 years. So there's no real answer, so we kind of skip that one. So, but you shouldn't get any negatives under the square root today when we're solving. All right, so what is this formula? If we zoom in on this formula right here, what does this mean? Okay, well, and why would we use it? So we have these letters here. We have a B, and we have an A, and we have a C. Let's first talk about the standard form of an equation. The standard form says that the first number that's attached to the x squared is your A. The number that's attached to your x is always your B, and the C is always going to be your constant. So that's what our standard form looks like, and that's what we've been doing a few times this unit so far, is we always make sure that we write it in the A, the B, then the C. So it's whatever squared comes first, and then whatever to the x multiplied by the x comes second, and then my number goes last. So an example that's up above would be this x squared plus 12x plus 16. So right below where I wrote. And if I label what my A, B, and C is in that example, I know that my A is 1, my B is 12, and my C is 16. So if you know those three things, there's an equation that will solve every quadratic equation that you see. No matter if it's factorable or not factorable, you can always use this formula right here that I'm circling. You can use it every single time. And that formula is x equals opposite of b. Then there's a plus or minus sign. So you're going to have two answers. The plus is going to be one answer, and the minus sign is going to be 2 answers. So you could really look at it like this, where it's going to be x equals opposite of b plus the square root of b squared minus 4ac all over 2a. And then your second answer is going to be x equals opposite of b minus the square root of b squared minus 4ac all over 2a. So there's going to be 2 answers here. They write it the quick way by doing a plus and minus sign right on top of each other. So that just means that there's 2 answers, one plus and one minus. So that's how you get your 2 different answers. So do one with a plus sign, one with a minus sign. You'll be good to go. Now, why did we do the simplifying radicals? Well, you'll notice in this equation there's a radical sign. So if you get a radical that can be simplified, we want you to simplify it today. The beginning is saying to do the opposite of b. So whatever number we get for b, like the example down below is 12, we'd put a negative 12 there. Okay, and then we take the b, the normal original b, and we square it. We subtract it with 4 times a times c. That's known as the discriminant. And then we always divide it by 2a. And if we take a look at the left side piece right here, right there, that's an equation that you should be very familiar with, or going to be very familiar with when you graph this, or if you have, I believe we have up to this point, graphed it. That's the equation to find the vertex of the quadratic equation. And the b squared minus 4ac, I believe we've done the discriminant so far, and it tells us how many solutions we have. If it's positive, it should be 2 solutions. If it's 0, it should be 1, because it'd be plus and minus square root of 0, which wouldn't change anything. And then if it was negative, it's going to be no solution. So now let's use this equation to solve this example. Now, you're asking yourself probably, why would I use this equation if it's faster when we factor it? And I agree with you. I wouldn't use this equation if it was factorable to begin with. But if I'm taking a look at this example and I try to figure out my factors of 16, I think that there's not going to be any that is going to add to give me the middle term. So that's why I use this equation, is when I'm stuck and I can't factor, I'm like, oh man, what do I do? Well, that's when we revert to this equation. So that's the only time that I use the equation. And this equation you're going to use a lot in Algebra 2, in geometry, when they ask you to solve quadratics that are not factorable. So you want to make sure that you know it and that you get good at it, you memorize it, because you're going to use it a lot. Actually, this one is like one of the most used, I'd say, probably top 3 that you're going to see. So the first thing that you want to do is find the discriminant. That's the b squared minus 4ac piece. So if I take my pieces up above, I know that my b is 12. So I'm going to do 12 squared minus, and then there's a 4. Then my a value is 1, and my c value is 16. So if I punch that into my calculator, 12 squared minus 4 times 1 times 16, I got 80. So 80 is my discriminant. 80 tells me that there should be 2 solutions because 80 is positive. That's what the discriminant tells you, how many solutions there are. So now we're going to put that 80 under the square root, because that is this piece right up here. That's where the 80 goes, is underneath that square root. And then it asks us to simplify 80. Well, 80, if I think about my perfect squares, I think if we go back up above here, 80 is right here, right before 81. So if I start dividing in my calculator, 80 divided by 64, that doesn't go into it evenly. 80 divided by 49, that does not go into it evenly. 80 divided by 36, that does not go into it evenly. 80 divided by 25 in my calculator gives me 3.2, that does not work. 80 divided by 16 gives me 5. So that's the winner. So I'm going to go back up. I'm going to split this into 16 and 5. And I know that 16 can be simplified. The square root of 16 is asking you what two numbers multiply by themselves to give me 16, and that's 4. So now we have a 4 square root 5. So we just took care of the square root piece. That's part of that equation. And the only other piece that we have to plug in now is the opposite of b over 2a piece that's on the left and underneath. So if we pop those in, the opposite of b, if I write this out, is negative 12. I know the plus and minus sign is going to give me this 4 root 5 because that's what I just found out for my discriminant when I put it under the radical. And then 2 times a is just 2 times 1 on the bottom. So that's just going to give me 2. So now in the end I have negative 12 plus or minus 4 root 5 over 2. Well, we're not done because we can try to simplify. So that means that can we divide out a number from all the numbers that are on the outside, not under the radical, but these numbers that are on the outside? Is there a number that goes into all three of them? Well, yeah, there is a number. I believe they can all divide by 2. So if they all divide by 2, I'd rewrite this as x equals negative 6 plus or minus 2, because if we divide it by 2, we get a 2 there. And then all over 1. We don't have to write the 1 if we don't want to. So you can just write it as negative 6 plus or minus 2 root 5. Some kids will ask that question, but we'd accept either one if you wanted to write it either way. They mean the same exact thing. All right, so that's the quadratic formula. It will work with every single problem that you have that's a quadratic equation. So anytime you see something squared, if you're not sure how to factor still or the factoring is tough for you, you can revert to this every single time. It always works. Whereas factoring will only work about half the time. So this is like the fallback option. So let's do a couple more examples here. So it's asking us to solve by the quadratic formula. The first thing that I always do is label what my a, b, and c are. That way I can get a good idea of what to plug into my equation. And then did they give us the equation? Oh man, I missed what's up top there. Oops. Okay, I'll do this one then. I'm sorry. So we have a is 2, b is 10, c is negative 15. I don't like that 15. I don't like that minus sign. Redo it. There we go. Okay, so now the first step is to find the discriminant. The discriminant will tell us how many solutions there are. If it's positive, there will be 2. If it's negative, there will be none, because you can't take the square root of a negative number. And if it's 0, there will only be 1, because plus 0 and minus 0 will not change your answer. So if we plug in this b squared, that'd be 10 squared minus 4 times a, which is 2, times c, which is negative 15. So give me a second while I punch that into my calculator, just like it's shown, even with the parentheses where they're at. So I have 10 squared minus 4, parentheses 2, parentheses negative 15. That means multiply when they're next to each other like that. And I get 220. So now it says to take that discriminant and put a square root over it and try to simplify it. So 220. I know that my perfect squares in my brain are these. All right, so let's see which one of these goes into 220 perfectly. So if I start with 225, oh no, 220 is before it, never mind. If I start with 196, so 220 divided by 196, that's 1.12, that does not work. 220 divided by 169, that gets me 1.3, that does not work. 220 divided by 144, that gives me 1.52, does not work. 220 divided by 121, nope. 220 divided by 100, that's 2.2, that does not work. 220 divided by 81. Does not work. 220 divided by 64. Nope, that gives me 3.43. 220 divided by 49. Nope. 220 divided by 36. Gives me 6.11. So that's no. 220 divided by 25. Nope, that gives me 8.8. 220 divided by 16. Oopsie. 220 divided by 16 gives me 13.75. 220 divided by 9. Are any of these going to work? 24.4. 220 divided by the last one. Of course, it's the last one. 220 divided by 4 gives me 55. So that means that I can break this into the square root of 4. That's my perfect square. That's for my list. And my remainder is 55. That's not on my list. So what's the square root of 4? Well, we should know that the two numbers that will multiply to give me 4 would be 2. So now I can pull out a 2 from the square root, and I'm left with 2 root 55. So that right there is what goes under the square root. So I just found this whole thing, the bottom left of my screen. I'm circling something right now. That's what we just found, is that whole thing should be 2 root 55. So from there, we're going to substitute the rest of it in. So the rest of it is just on the left side there. So it'll be x equals opposite of b. So b we said was what, 10? So now opposite of b would be negative 10. We know that the plus and minus sign is going to be this 2 root 55. And the bottom is 2 times a, so it's 2 times 2. So in the end, that gives me negative 10 plus or minus 2 root 55 all over 4. And then I look to see, is there a number I could divide out from all three of the outside terms? I don't mess with anything on the inside of the radical. So on the outside of the radical, I have a 10, a 2, and a 4. I think a 2 goes into all three of those, so I can divide out a 2. So that's negative 5 plus or minus 1 root 55 over 2. And that would be my final answer after I simplified. So x equals negative 5 plus root 55 over 2. Or your other answer would be negative 5 minus root 55 over 2. So there's two different ways to write it. You can write it separately with a plus sign and a minus sign, or you can just stack the plus and minus sign just like I did up above, and that's a little bit faster for you. All right, so let's go to this example that I almost did because I didn't see the top half of your notes. So number one, if we label the a, b, and c, we get 2, 2, and negative 1, looks like. So if we were to find my discriminant first, that's this one, the b squared minus 4 times a times c. So that's what it asked me to do first. So b squared is 2 squared. 4 times a is 2 times c is negative 1. So if I punch this in my calculator, that gives me 4 plus 8, and it gives me 12. So that's what you should have gotten when you did b squared minus 4ac for this one. The square root of 12 can be broken into 4 and 3. So I'm left with 2 root 3 when I simplify that. So then from here, I set up the rest of my equation. I know it's opposite of b plus or minus my discriminant all over 2 times a. So I'm just going to plug in my pieces that I need. I know that opposite of b is negative 2. I know that I have my discriminant square rooted already to the left there. So I'm just going to bring this 2 root 3 up and plug it in always after the plus and minus sign, whatever I find my discriminant is under the radical, simplified. And then 2 times a would be 2 times 2. So now my final answer is negative 2 plus or minus 2 root 3 over 4. No, it's not final because I can simplify all the numbers on the outside. So I can divide them all by 2, I believe, again. So if we divide them all by 2, we get negative 1 plus or minus 1 root 3 over 2. So that would now be my final simplified answer. So that's how you do the quadratic formula. And once again, that will work on every single quadratic equation that you have. All right, let's check out Let's check out number 2. Yeah. So if we label my A, B, and C first, A is 1 because there's just a 1 in front. B is -10, and C is 5. So if I were to find my discriminant, I get -10 squared minus 4 times 1 times 5. So that'd be 100 minus 20, and that would give me 80. So then from there, I'm supposed to find my square root of that. Square root of 80, I think 4, 9, 16, 25, 36, 49, 64, 81. Oops. 81. All right. So now 80 is right here between these two. I start dividing back in my calculator. It doesn't go in evenly. It does not go in evenly. It does not go in evenly. It does not go in evenly. 80 divided by 16, I believe, does go in evenly. I believe that's 16 times 5, if I did that right. And the square root of 16 is just a 4 now. So that would be my discriminant and taking the square root of it. So now I just got to set up the rest of my quadratic formula. That's opposite of b. So it's -10 to begin. So the opposite of -10 is +10. I have a plus or minus 4 square root 5. And 2 times a is 2 times 1. So now my final is going to be 10 plus or minus 4 root 5 over 2. And again, that's not my final answer because I could divide everything that's on the outside. So if I divide it all by 2, I get 5 plus or minus 2 root 5 all over 1. I don't have to write it over 1 if I don't want to, but you can. So I'll write both my answers. So minus 2 root 5 over 1. You could write it like that too if you wanted to. Either one would be acceptable. All right, so let's, why don't you pause it here and see if you can figure out the discriminant, and then we'll meet you back. So give it a pause, and we'll see if you can figure out at least the b squared minus 4ac part. All right, welcome back. B squared minus 4ac. Oh, let me label them first. I almost forgot about that. So if we label these, we get 3, 2, and -4. So if I did this correctly, it'd be 2 squared minus 4 times 3 times -4. So it'd give me 4 plus 48, I believe. So hopefully you got 52. And then you're supposed to take the square root of 52. All right, the biggest perfect square that goes into it, I believe, is 4. 13 times. 4 times 10, 40. 4, yeah. So now we have a 2 root 13 in the end when we simplify. So now we got to set up the rest of my quadratic formula. So why don't you pause it here and see if you can set it up, see if we get the same answer. All right, welcome back. So we'd set it up as doing the opposite of b, plus or minus my 2 root 13, all over 2 times a, which is 2 times 3. So in the end, that'd be -2 plus or minus 2 root 13 over 6. And I believe that we can divide a 2 from all three terms on the outside. So if we divide out a 2, that'd be -1 plus or minus 1 root 13 over 3. That would be my answer for number 3. All right, last one. So if we take a look at my last one, and we label my A, B, and C, we get 1, 3, -10. You can pause it if you want and see if you can do it all the way through. And then you can press play and see if we got it. All right, so b squared minus 4ac. Finding the discriminant is always the first step. So that'd be 9 plus 40. So that's 49. I take the square root of that. I get 7. So now if I set this up correctly, it'd be opposite of b, which is -3, plus or minus just the 7 that I got. There's no square root since it was a perfect square. All over 2 times a. So now I get -3 plus 7 over 2. or negative 3 minus 7 over 2. So when I don't have a perfect square left, I can actually solve this. So in my calculator, if I actually added and divided and simplified, I believe I'd get 4 over 2, which is x equals 2. And this one, I get negative 10 over 2, which is x equals negative 5. So those would be my two answers. Now the funny thing is here, and many of you probably didn't realize, is that the quadratic formula wasn't the only way that you can solve this. Since there's no square root left, you could have solved it by factoring. So we could have found out the two numbers that multiply to give me negative 10, but add to give me positive 3. And that would have been plus 5 and minus 2. So we would have gotten the same exact answers of negative 5 and 2, going by factoring, solving that way, or solving by the quadratic formula. Now this is something difficult. I know it's going to take a little bit to get used to and to figure out the equation. That's okay. It usually takes a day or two to kind of work through this. I think if you do the notes and then you do the homework, and then tomorrow we're going to make sure we have some questions again, you're going to be ready to go for the Khan Academy quizzes. All right, have a good day. Take care.